Hello everyone, myself Pranjali Mishra, and today we are going to solve question number 1 of the video series for the subject Computer Oriented Numerical Method. Test number 1, question 1. Write an algorithm flowchart to solve the following pair of equation for x and y given the value of a11, a12, a13, a21, a22, a23. We have given two equations, this and this. We have given four cases, case 1, case 2, case 3 and case 4. According to these cases, we have to solve two parts. The first one is comment on a result of case 1 and case 2 when there is a change of 0.001 in one of the coefficient. Case B, how interchange of equation affects the solution in case 3 and case 4. Let's start with the approach. Assume the set of equation instruction to solve the following pair of equation for x and y given the value of a, b, c, p, q and r. A of x plus b of y equals to c. P of x plus q of y equals to r. We have given both this equation a name. The first name is 1.1 and the second is 1.2. Let's assume that a, b, c, p, q and r are a non-zero. We have from equation 1.1 the value of x will be c minus by divided by a. We name this equation as 1.3. Now let's substitute the value of x in equation 1.2. P of x plus q of y equals to r. Now by substituting the value of x, that is c minus by upon a, we get y into q minus pb by a equals to r minus pc by q, which we named as 1.4. Thus, if we compute q minus pb by a and replace the value of q by it, and then compute r minus pc by a and replace the value of r by it, we have y equals to r divided by q. We can substitute the value of y in the equation 1.3 and then we will find the value of x. Let's further go with the algorithm. Step 1. First, we're gonna read 6 numbers and assign them respectively to a, b, c, p, q and r. Step 2. Compute this value, replace the value of q by this value. Step 3. Compute this value and replace the value of r by it. Step 4. If q equals to 0, then write no solution and stop, else continue. Step 5. Set y equals to r divided by q. Step 6. Set x equals to c by minus a. Step 7. Write the value of x and y as answer. Step 4. Stop. The first part, comment on a result of case 1 and case 2 when there is a change of 0.001 in one of the coefficient. We have given case 1 and case 2 here. According to our algorithm, we gonna replace a, b, c, p, q, r as a11, a12, a13, a21, a22 and a23. We have given two equations above in the question. So solving this equation like this, if we solve the equation using algorithm, we will compute the value of x1 and x2. By solving this value, we're gonna get the answer as 0.32794 E2. Again, we will get the value of x1 and x2 after setting and computing this. Now for case 2. If we solve the equation using algorithm, we will compute the value of x1 and x2, that is q minus pb by a. We get the value of x1 and x2 as minus 0.3217 E2. x2 is equal to 0.166 E2. Thus, we observe that the two solutions agree in two most significant digits. The reason for the disagreement in the two solutions is due to loss of significant digit when the difference of two almost equal number is taken. We observe that if we are changing the value of q, that is a22, to 2.606, and the value of all the other variables are kept the same, we observe that there is a change of 0.01 in one of the number. The solution we obtain is x1 equals to 0.2352 e2 and x2 is equal to 0.1250 e2. Thus, the reason for the sensitivity is due to the fact that the straight line representing the two equations are almost parallel, and a slight change in slope of one of the straight line changes their point of intersection. Such kind of problem is said to be ill condition. Let's move toward the B part. How interchange of equation affect the solution in case 3 and case 4. We have given two cases, case 3 and case 4. Consider the following set of equation, and the value for the coefficient for the simultaneous equation is like this. Using 4-digit mantissa and floating point arithmetic, the solution we get x equals to 0 and y equals to 1, which is obviously wrong. If we interchange the equation, we have x plus 2y equals to 4. 0.2 e minus 4x plus 2y equals to 2. So, the coefficient are set as a11 as 1, a12 as 2, a13 as 4, a21 as 0.2 e minus 4, a32 is equals to 2.00, a23 as 2.00. With the set of coefficient, if the algorithm is executed in floating point arithmetic, the solution is x equals to 2 and y equals to 1, which is nearly the true solution. X equals to 2.4 times 0, 4, and y equals to 0.94 times 9, 8. So, we have seen by the above solution that the interchange of equation brought about a significant improvement in the equation solution. The reason is that in the fourth case, we avoid division by a small quantity, and this leads to a reasonable solution. That's all for question 1. Thank you.